How do elasticity and plasticity relate to material brittleness? Imagine bending a paperclip and it springs back, or bending a piece of metal and it stays bent. These are simple ways to see elasticity and plasticity in action. Now, what about brittleness? It's a different story. Some materials snap or shatter with very little warning. Understanding how elasticity and plasticity connect to brittleness helps us see why some materials break suddenly while others bend or deform first. Elasticity is a material's ability to stretch or compress and then return to its original shape once the force is removed. Think of a rubber band stretching and snapping back. When a material is elastic within its elastic limit, it deforms temporarily but recovers fully. This behavior follows a rule called Hooke's law, where stress and strain are directly proportional. Plasticity is quite different. It describes how a material can undergo permanent shape change without breaking. When stress exceeds the elastic limit, the material enters the plastic region and deforms permanently. Metals like copper or aluminum show this behavior, allowing them to bend and still hold their shape. Brittle materials are quite the opposite of plastic ones. They tend to fracture with very little deformation. Imagine a glass breaking when dropped or a ceramic cracking under pressure. These materials have low plasticity, meaning they do not bend or stretch much before breaking. They often have high elasticity up to their breaking point, but once that point is reached, failure happens suddenly. Because they cannot absorb much energy through deformation, they tend to crack or shatter without warning. Now, how do elasticity and plasticity relate to brittleness? If a material is highly elastic but has low plasticity, it can stretch a bit but will break suddenly once its strength is exceeded. This is typical of brittle materials. They can handle some deformation but not enough to prevent failure. On the other hand, materials with both elasticity and plasticity can deform more before breaking. They can stretch elastically and then undergo plastic deformation, which helps distribute stress and prevent sudden failure. Metals like steel or aluminum fall into this category and are less brittle because they can bend and absorb energy. In essence, the more a material can deform plastically, the less brittle it is. Materials with high plasticity can bend and stretch, absorbing energy and avoiding sudden cracks. Those with low plasticity tend to fracture quickly, often with little warning. This relationship explains why some materials fail suddenly and others give signs of failure through deformation. For engineers, knowing this helps in choosing the right material for the job. If a structure needs to withstand shocks or overloads, selecting a material with good plasticity reduces the risk of sudden failure. So, in simple terms, elasticity is about bouncing back, plasticity is about bending without breaking, and brittleness is about breaking with little to no warning. The more plastic a material has, the less brittle it is, and understanding this balance helps us create safer, more reliable products and structures.